takes a lot of courage to sail or fly around the world. Many have tried but failed, but many have succeeded. It's not impossible. It's like modern mathematics. You may not be the top gun with your scores, but at least if you master one topic and you do good at it, it could take your confidence level from down here to up there. And who would have guessed it? Today's topic is the Earth as a sphere. Are you guys ready? It's all yours, Cikgu Noel.
Okay, thanks Razif. Now, are you guys ready? Ready for Earth as a sphere? Let's go! Okay, so let's take a look at our first question for today. Now, in this question, we have a diagram and it is given that N is the North Pole while S is the South Pole. Now, NOS is the axis of the Earth and we are supposed to state the positions of A, B, C and D. Here, you are asked to specify the positions of A, B, C and D. Now, when position is mentioned in Earth as a sphere, you must understand that you must specify both the latitude and the longitude of the point. For point A, you can see that point A is at the angle of elevation of 65 degrees from the equator. Therefore, its latitude will be 65 degrees north, and as the diagram shows, it is sitting on the longitude of 50 degrees east. Thus, the position of A is 65 degrees north and 50 degrees east. While as for point B in terms of latitude, it is at an angle of depression from the equator at 40 degrees. Therefore, the latitude for point B is 40 degrees south, and it is sitting on the longitude of 50 degrees east. Now, the position of B is then 40 degrees south and 50 degrees east. Well, for point C, it is seated directly on the equator. Therefore, the latitude is at 0 degrees north, and it is seated on the longitude of 60 degrees west. Therefore, the position of C is at 0 degrees north and 60 degrees west. Now, for point D, it is seated on the parallel of latitude with point A. Since we know that point A is at a latitude of 65 degrees north, point D will then be at the same latitude. So in this diagram, it shows that D is at the same great circle as point A and B, which means to say that the longitude of A is exactly 180 degrees apart. So, from the meridian Greenwich, the longitude of A is 50 degrees east, and therefore the longitude of D will be 130 degrees west. And that is how the longitude of point A and D is exactly 180 degrees apart. So the location of point D is 65 degrees north and 130 degrees west.
While we take a quick break from the questions, let me give you a piece of advice if you want to travel around the world. Bring some water. Okay, let's go to another question.
Alright, here we are given a question where N is the North Pole, S is the South Pole, and O is the center of the Earth. Now, the first clue that is given is that PQ is the diameter of the Earth, and we are supposed to look for the position of Q. Now, knowing that PQ is the diameter of the Earth, we are able to utilize the latitude of P to find the latitude of Q. Now, realize that P is at the latitude of 55 degrees north, therefore Q will definitely be on the latitude of 55 degrees south. Now, this is because the same angle of elevation from the equator to P will be the same angle of depression from the equator to Q. So we can conclude that the latitude of point Q is actually 55 degrees south. Now, the next thing that we're going to figure out is the longitude of point Q. Since PQ is the diameter of the Earth, it means that point P and point Q are sitting on the same great circle. In other words, the longitude of point P is exactly 180 degrees apart from the longitude of point Q. So if the longitude of point P is 80 degrees to the east, then the longitude of point Q will be 100 degrees to the west. So this totals up to 180 degrees apart. Therefore, the position of point Q can be summarized as 55 degrees south and 100 degrees west. Now in part B1, we are supposed to calculate the distance of PT in nautical miles, measured along the longitude of 80 degrees east. Now, 1 nautical mile is the length of an arc of a great circle which subtends 1 minute at the center of the earth. Therefore, it must be measured along a great circle. Since point P and point T are sitting along a great circle with the longitude of 80 degrees east, therefore, to calculate the distance between them, all that needs to be done is to calculate the angle subtended at the center of the earth by the arc joining these 2 points. Well, in this case, it is equivalent to the difference between the 2 latitudes. The latitude of P is 55 degrees north and the latitude of T is 0 degrees north. So the difference between them is 55 degrees. Okay, next we have to convert degrees into minutes. So 55 degrees will multiply by 60 to form 3,300 minutes. And since each minute contributes to 1 nautical mile, therefore 3,300 minutes will contribute to 3,300 nautical miles. So that is the distance of PT. Now, in this part, we have to find the shortest distance of UT in nautical miles measured along the equator. Now don't forget, the equator is a great circle. Therefore, to calculate the distance of UT, all we have to do is find the angle subtended at the center of the earth by these 2 points and convert them to minutes. Now that will be equivalent to the distance. So since the angle subtended by points U and T is 80 degrees, we multiply that by 60 and we have 4,800 minutes. Now since each minute contributes to 1 nautical mile, therefore 4,800 minutes will give you 4,800 nautical miles.
Now, what was the name of that guy who traveled around the world in a balloon in 80 days again? Was it Phileas Fogg or Jackie Chan? Ah, gotcha! Of course it's Jackie Chan. Who's Phileas Fogg? I don't know Phileas Fogg. We'll be right back after this when I find out who Phileas Fogg is. Who's Phileas Fogg? Who's this Phileas? So, where were we? Oh yes, tales of adventure! But now, it's back to math and more math.
Okay, 谢谢你 Razif. Alright guys, are you ready for more questions? Because right now I have one right in my mind and here it is. Okay, now in this question we have points A, B, C and D that are sitting on the surface of the earth. And the clue that is given to us is that AB is the diameter of the earth. So the first thing that we're going to do is to find the longitude of B. Now the clue is that AB is the diameter of the earth. So if AB is the diameter of the earth, that means that they are sitting on the same great circle and the angle between the longitudes are exactly 180 degrees apart. Now therefore, if the longitude of point A is 20 degrees east, then the longitude of point B should be 160 degrees west.
We are now supposed to calculate the shortest distance in nautical miles from B to the North Pole measured along the surface of the Earth. Now, from B to North Pole, it is along the meridian which is also part of the Great Circle. Therefore, all that needs to be done is to find the difference in angle from the latitude of point B to the latitude of the North Pole. We know that the North Pole is 90 degrees from the equator. Now the problem now is to find the latitude of point B. By referring to the hint that AB is the diameter of the Earth, we understand that the angle of elevation from the equator to point B will be exactly the same as the angle of depression from the equator to point A. So if the angle of depression from the equator to point A is 52 degrees, Therefore, the angle of elevation from the equator to point B will be 52 degrees as well. So the latitude of point B is 52 degrees north. And the angle now between point B and N will be 90 degrees minus 52 degrees, which gives you 38 degrees. So converting degrees into minute, we have 2,280 minutes. And since 1 nautical mile is equivalent to 1 minute, therefore the distance of BN is equivalent to 2,280 nautical miles.
Now, here we are given that point C is 3,000 nautical miles due north of A. If C is due north of A, that means that the distance from A to C is along the meridian. So the first thing that we need to do is find the angle subtended between A and C to the center of the Earth.
And for the last part of this question, we are given that D is due west of A and its longitude is 30 degrees west. We have to calculate the shortest distance in nautical miles from D to A as measured along the common parallel of latitude. Now, for distances along a parallel of latitude, we have to find the angle subtended by the 2 points at the center of their parallel of latitude, and we have to convert the angle into minutes, and on top of that, we have to multiply by cos theta, where theta is the angle of elevation or depression from the equator to that parallel of latitude. Now, it's pretty much the same calculation as distance between 2 points along the equator, but because parallel of latitudes are not a great circle, therefore we have to multiply by cos theta. So if the point is on the longitude of 20 degrees east and point D is on the longitude of 30 degrees west, technically these two longitudes are 50 degrees apart. Now remember, if one longitude is on the east and one longitude is on the west, add the two angles to find the angle between them. And if they are on the same side, then take the difference between their angles. Thus, the angle between A and D is 50 degrees, and that is equivalent to 3,000 minutes, and after multiplying by cos 52 degrees, the distance is 1,847 nautical miles.
Okay, so that's all we have for this episode. It has been fun and really great, but right now we got to go all the way back to Brazil.
Now, you may ask yourself, why would I want to choose such a difficult topic? Well, Earth as a sphere is guaranteed to come out every year on both paper 1 and 2. If you understand the basics, you will nail it. The formulas for longitude and latitude are simple. The tricky part is using the information given and remembering in which direction the points are located. We'll see you next week on Top Tutor SPM Modern Mathematics. Ciao!